Greetings. Hope you're having a great day. Here's our Chapter 2 test. Okay. We're doing this on the Edulastic site, so have your Chromebook and everything filled in. Have another tab ready to enter your responses. So, without further ado, here we go. Question number 1 here. I want you to determine what's the next shape in the pattern. And I gotta show you that here's the spots that are colored in. It's a little hard to see on this from the copier. So there's the original parts that are shaded. So A, B, C, or D, which one's the next one in the pattern? Okay. Speaking of patterns, we're to write the next number, just the next number in this pattern. Okay. So who's the next number in this pattern? Look at how the numbers are changing and going from 2 to 4 to 8 to 6. On number 3, we're to pick which one of these, and we could pick as many as what we need, that shows that they're a counterexample. So which of these choices, A, B, C, D, E, or F, is a counterexample to this statement? All quadrilaterals are equilateral. Okay, equilateral meaning all the same sides. So you got a rectangle, square, parallelogram, rhombus, kite, and a trapezoid. Which ones prove that this is false? This is a false statement. Which one of these says that, yeah, you're right, all quadrilaterals are equilateral? That's not true. They're not all equilateral. So which ones prove that? I also drew pictures, as you can see here, to kind of help guide you in your decision making. Okay, so you can kind of take a look at those there and help determine which ones prove that that statement is false. So click any of them that apply, and I will tell you there are 1, 2, 3, 4. There are 4 answers here. In question number 4, it says, for this statement, soccer players are athletes. Match each statement with the appropriate name. So, here's the statements. You're going to drag and drop these boxes over here to the ones that match. So you got, and I crossed out the biconditional. This is not one of the choices. So you get the if-then statement, the converse, okay, which is just the when you flip this around. The inverse, which is when they start adding negative words. And then the contrapositive is just the opposite of the inverse. So you have, if you are not an athlete, then you are not a soccer player. If you are an athlete, then you are a soccer player. If you are not a soccer player, then you are not an athlete. If you are a soccer player, then you're an athlete. So match if then, converse, contrapositive, and inverse to these. If you need help, let me know. In number 5, we'd like you to rewrite this statement. Collinear points are points that lie on the same line, using the if and only if biconditional piece. Okay? So, for example, I would say, My example could be such as the Cleveland Browns will go to the Super Bowl if and only if all the other teams in the NFL quit for the season. So take collinear points, are points that lie on the same line, and just add these words if and only if in the right spot, and rewrite that down below. Okay, number 6, using the law of detachment or law of syllogism, make a valid conclusion. So here's our situation. What conclusion can you draw from this statement? If you save $30, then you can buy a CD player. You have saved $30. So what's our conclusion? Don't overthink this. Write it down here in the bottom. And then there's a part B to this question. Which law used to draw your conclusion? Was it law of detachment? Think detach. We're kind of pulling something out. Or is it law of syllogism, which is kind of more like the transitive property? Which one did you use there in part A to get your answer? And number 7, what conclusion can you draw from this statement? Again, we're talking about detachment or syllogism here, just like the last one. If 6x equals 30, then x equals 5. If x equals 5, then 2x equals 10. So what's our conclusion? Okay. You can write that down below. And then also part B again. Which of these, law of detachment or syllogism, was used in that example? Okay, and number 8, guys, keep your thinking caps on here. We're just going to choose which word would go here to fill in the blank, okay? So just click and drop down, I believe. So it's either must have, may have, or never. So read it. And you can even read it quietly to yourself. The Empire State Building is in New York City. Sam vacationed in New York City. So Sam must have visited the Empire State Building. Sam may have visited the Empire State Building. Or Sam never visited the Empire State Building. Which is it? Question number 9. Just like the last one, we got some words we're going to put in. The words are is not, and maybe. Make sure I got all this question. Okay, I do. So, some tourist sites in New York City are accessible when accompanied by a tour guide. So Sam is visiting tourist sites in New York City with a tour guide. Or is it Sam is not visiting tourist sites in New York City with a tour guide? Or is it Sam may be visiting tourist sites in New York City with a tour guide? Again, if it helps those last two, read them quietly to yourself, but keep reading that full sentence, adding the word, and seeing which one fits in the best. Okay, guys, and number 10, you're to solve this equation, okay, and write the postulate or theorem. So you're going to drag and drop one of these for each of these two boxes, okay? So let's take a look at the problem. Whoops, zoom in. And you can see from the beginning of the equation to the next step, they had to add 21. Okay? So you then need to put one of those properties over here. Then here's what the next step was they did. Okay? So then you put, what did we do right here? Right there to get the answer. And your choices for that problem are addition property of equality. That's what POE means again, property of equality. Multiplication property of equality, substitution property of equality, division property of equality, the distributive property, or the subtraction property of equality. Okay, number 11, again, we're going to drag and drop. They're solving an equation here. You have drag and drop your reasons over here on the right. Your choices are distributive, subtraction, substitution, addition, division, or multiplication. So let's zoom in here and I'll kind of show you the steps again. I would do that first to both sides. And then, to get rid of that fraction, that's the reciprocal. Whoops. It's not 5. Donkey. Okay. So, you need to choose who goes here from your choices on the left there. Same thing here in question number 12. Are we dealing with the subtraction, addition, multiplication, or substitution, or division properties of equality, or is it the distributive property? So again, I'll zoom in. And here's what I would do if I were solving. Just like solving equations that you guys have done 1,000 times. So there you go, there's your steps. Drag and drop. What's the reason behind each step when they solve? Alright gang, last two questions. Angle ABD and CBE are straight angles. Straight being a huge word right here. So which two theorems can you use to prove that ABC and DBE are congruent? So you got to draw on your picture here. Maybe if you draw an example of this on your scrap paper, that would be prudent. But okay, let's first label this first part that they gave us up here. ABD, that is this dude right here, this straight line right there. And CBE, they're just saying, yeah, they're straight angles. Straight angle is just a line. Okay. So that's what they gave us. And they want us to prove that ABC and DBE are equal. So that would be ABC, that would be this angle right here, and DBE, those angles right there. So here and here. So which of these theorems proves that? Is it congruent supplements, right angle congruence, congruent complements, linear pair, or vertical angles? So look at these guys. When two lines cross, we know that these opposite angles are equal. Which one of these tells us that? Alright, boys and girls, last problem. It's a proof. It's not that bad. Okay. Mr. Houston's already got the statements typed over here. You just got to drag and drop these over here to the right side for the reasons. So you got two givens. One that it means simplify. One that's definition of a right angle. And one that's definition of an angle bisector. Remember, bisector cuts things in what? So let me read the given information to you. Up here. Angle ABC, that's this big dude right here, is a right angle. And they marked it right here with this square. Okay. segment, or that's a ray, BD, that's this dude, is an angle bisector. So he's an angle bisector, which means he's splitting this big one in half, which means these two smaller parts are going to be what to each other? So keep that in mind. We're proving that DBC, right here, this angle, is 45 degrees. So, again, you got two givens, simplify, definition of right angle, and angle bisector. So your first step, angle ABC is a right angle. Second step, the measure of ABC is 90 degrees. So which of these over here would talk about ABC being 90 degrees? BD is an angle bisector. Is it one of these, or did that maybe come from up here? You got to make sure you look. We got two givens, guys. There's two given statements up there. Where do they go over here? DBC equals 90 degrees divided by 2. Which of these would apply? And then DBC equals 45. Alright. That's it for your test. I don't think that was too bad. A couple of them were a little tricky. If you have questions, go back over it, look it over, take your time. Have a great day. God bless.